Okay, in this tutorial we are going to explore how to graph exponential functions in the form y is equal to a times b to the x minus h plus k, where a is not equal to 0, b is greater than 0, but b is not equal to 1. I'll let you on your own determine why I don't want a to be equal to 0 or b to be less than or equal to 0 or equal to 1. All those would cause problems for my exponential functions. Before I begin to actually work on some functions on my own, I thought I'd look some at the graph. So I put up some graphs of some of the different functions that we might have. On the first one, I've given us three graphs. f1 of x, which is the blue graph, is 2 to the x. My red graph is 3 to the x, and my black graph is 5 to the x. They have a lot in common. They all show exponential growth, meaning that as x gets bigger and bigger, as x approaches infinity, f of x also approaches infinity. Also, as x approaches negative infinity, these graphs look like they're touching the x-axis. Actually, they get closer and closer and closer to the x-axis, but never touch it. I don't know why that does that, but it drives me nuts. Okay. All right, now, the reason I know it doesn't ever touch the x-axis, let's take a look at like f1 of x, the blue graph, and let's do 2 to the negative 10, which looks like it really is right on the axis. Well, remember 2 to the negative 10 is 1 over 2 to the 10th. 1 over 2 to the 10th is very, very small, but it is greater than 0. That's going to happen for any x value you put in. But notice here when I have an a value, implied a value of 1. My b value for all three of these graphs is greater than 1. And in every single case, I get exponential growth. Compare that to this graph, where now I have three graphs where the b value is all less than 1. In f4 of x, my b value is a half. In the green one, it's a third. And in the orange one, it's a fifth. These are all exponential decay. Notice that they still go through that point 0, 1. I hope I said that. This has an intercept at 0, 1, all three graphs. All three of these graphs have an intercept at 0, 1. However, in this case, as x approaches infinity, they're all getting closer and closer to 0. f of x is approaching 0. For the next graphs, what I did was I decided to give an a value different than 1. So my black graph is once again y equals 2 to the x. Then the blue graph is y equals 3 times 2 to the x. Notice that they're both exponential growth, but in this particular case, for the blue graph, my y-intercept is 0, 3. And in my red graph, the y-intercept is 0, 4. It is not coincidence that in the black graph, my a value is 1, and I have an intercept at 1. My blue value is 3. I have an intercept at 3. And my red value is 4. I have an intercept at 4. 0, 1, 0, 3, 0, 4. Notice that's where my intercept is coming from. In this next graph, other than this stupid Google thing taking off on me again, what I've tried to show is a horizontal reflection. The black graph is y equals 2 to the x. We've looked at that a couple times already. And then my purple, fuchsia, whatever color graph here, is y equals 2 to the negative x. Well, what's that negative x do? Clearly, that's a horizontal reflection. However, the graph y equals 2 to the negative x is definitely exponential decay. It looks exactly the same as the graph y equals 1/2 to the x. Well, we'll show you in case you've forgotten again. 2 to the negative x is the same thing as 1 over 2 to the x, which is the same thing as 1/2 to the x. It really is the exact same graph. Then finally, I thought I would also show you a vertical reflection. The green graph, y equals 2 to the x. We've seen it many, many times. My orange graph here is y equals negative 2 to the x. It's exponential growth, but it's actually growing in the downward direction. Why? Because when I put that negative in front of any function, it flips it vertically. Okay. So hopefully get an idea of what these graphs look like. They all have the same basic shape. And even as we translate them left, right, up, and down, you're going to continue to see that basic shape. All right, what I did, some people have enjoyed my idea of how I came up with a little flow chart. Basically, in order to know if we have exponential growth or if we have exponential decay, I always start right here saying, okay, well, let's start with it being growth unless I find out it's not growth. And the only two things I need to look at is b greater than 1 or is it less than 1? And is there a negative in front of the x value? Okay. Starting at growth, if b is less than 1, that's going to toggle me from growth to decay. If b is not less than 1, it's not going to toggle me. I'm going to be sitting there at growth. Okay, the b value here. Is it less than 1? Is it greater than 1? We saw that in the first two sets of graphs we looked at just a few minutes ago. Once I've got toggle from b is less than 1, I look to see, is there a negative in front of the x? Well, I don't know if we've seen any yet, but you could possibly something along the lines of y is equal to 3 to the 5 minus x. Okay, which is the same thing as negative x plus 5. Notice that now there is a negative in front of the x. When you see that negative in front of the x, it's going to toggle you again. So if you're at decay, it would toggle you to growth. If you were at growth, it would toggle you to decay. And if it hasn't changed, your toggle will stay the same. If that works for you, great. If it doesn't, no big deal. But that's just the way, as a computer person, I always think of zeros and ones, the way I kind of determine whether I'm going to have exponential growth or exponential decay. What I've done on this slide is I've given you a little algorithm that kind of goes through my head as I get ready to graph them. The first thing I do when I'm graphing exponential functions is I look to see where is my horizontal asymptote. And it's real easy. The horizontal asymptote is just at this k value, the value at the very end of my function. Okay. Then I'm going to determine 3 points on the graph using x equals h minus 1, x equals h, and x equals h plus 1. Instead of spending a whole lot of time explaining to you what that means, once I do a few examples, I think you'll see where I'm going with that. Okay. These graphs have a domain from negative infinity to infinity, so they will always have a y-intercept. And you can always find the y-intercept by setting x equal to 0. These graphs may or may not have an x-intercept, and if they do, you may or may not be asked to find them. A lot of times they wait until we've gone over logarithms before we make you do an x-intercept on an exponential graph, but I'll do one to give you the x-intercept just in case you're asked to do that also. And then basically once I've got all my points, I've got my horizontal asymptote, I'm just going to complete the graph by connecting all the points together. All right, well, let's look at one we've already seen, y equals 2 to the x, and let's see if we can follow along with my algorithm. The first thing I notice, there's no value outside the 2 to the x. It's a 0, and so I have a horizontal asymptote at y equals 0. The next thing I'm going to do is I'm going to look at the points where x, I'm going to set whatever that exponential value is equal to 0, and I'm going to actually make 3 points. I'm not real big on t-charts, but in this particular case, they're really not bad to have. The middle point is going to be whatever makes that thing 0, so in this case it is a 0, and I'm going to go 1 behind it and 1 in front of it. Now, what is 2 to the 0? Well, anything other than 0 to the 0 power is 1. Okay. What is 2 to the 1? Well, 2 to the 1 is 2. And finally, what is 2 to the negative 1? Well, that's the same thing as 1 over 2 to the 1, which is a half. So if x is negative 1, my y value is a half. And let me go ahead and graph these things. I've got the point negative 1, 1 half, and I'll label them after I get them all put on there. 0, 1, and 1, 2. And I'm going to connect my points. I'm going to get closer and closer to this asymptote. I don't have a vertical asymptote. This just graph is going to head up to positive infinity. If you need to choose more points up here to figure out the exact way the graph goes, that's fine. I'm usually okay with my students as long as you make sure that it heads up to positive infinity. Okay, now here's the point. Once again, this is point negative 1, 1 half. This is the point 0, 1, and this is the point 1, 2. I always like to have those labeled. The domain of this graph, as of any exponential function, is negative infinity to infinity. And the range of this function, notice I never get a 0 value or any negative value. The range goes from 0 to infinity. Make sure you have a parenthesis around that 0 because 0 is not part of the range. All right, let's look at one that's a little bit tougher. How about y is equal to 3 to the x plus 1 minus 2? I don't know why it got so small, but it doesn't really matter. Once again, I look here first. I'm going to have a horizontal asymptote at y equals negative 2. So let me put that down first. Got my horizontal asymptote. Y is equal to negative 2. Okay. And then I look at the exponent. What value of x for the exponent is going to give me a 0? And the answer is -1. So when I get ready to do my chart, my middle value is going to be -1. I'm going to go 1 behind -1, which is -2, and 1 in front of -1, which is 0. And I'll use those 3 points to help guide my graph. Okay, if x is equal to -1, I'm going to get 3 to the power -1 plus 1 minus 2. Well, that's 3 to the 0 minus 2. 3 to the 0 is 1. 1 minus 2 is equal to -1. And so when my x value is -1, my y value is -1 also. What happens when my x value is 0? I'm going to get 3 to the 0 plus 1 minus 2, which is 3 to the 1 minus 2, which is 3 minus 2, which is equal to 1. So when my x value is 0, my y value is +1. And then finally, when I use -2, 3 to the power -2 plus 1 minus 2 is going to be equal to 3 to the -1 minus 2. Well, 3 to the -1 is 1 over 3 to the 1, so it's 1/3 minus 2, and 1/3 minus 2 is -1 and 2/3. So when x is -2, my y value is -1 and 2/3. All right, I've got a horizontal asymptote. I've got these points. Let me plot them real quick. -2, -1 and 2/3. And I'll label them a little later. -1, -1. And 0, 1. Okay. And now I'm going to go here. Let me label 0, 1. Let me label -1, -1. And let me label -2, -1 and 2/3. Now look, I've got an x-intercept this time. You may or may not be asked to label the x-intercept, but let me do it just in case. The way you label the x-intercept, notice I've got the y-intercept already. The way you label the x-intercept is by setting y equal to 0 and solving. And once again, if you don't know logarithms, don't worry about this yet. 0 is equal to 3 to the x plus 1 minus 2. I'm going to add 2 to both sides. 2 is equal to 3 to the x plus 1. Now I'm going to have to take a logarithm, right? And so if I've got 2 is equal to 3 to the x plus 1, I'm going to take the log base 3 of both sides. The log base 3 of 2 is equal to x plus 1. Well, the log base 3 of 2 is pretty much telling me 3 to what power is equal to 2. I know 3 to the 0 is equal to 1. And I know that 3 to the 1 is equal to 3. So if I want to get a value of 2, my x value has to be between 0 and 1. I have a number between 0 and 1. And I subtract 1 from it over here. My number is going to be between -1 and 0, so I feel pretty good about my answer. Now, if I want to actually put what this point is, the x value is going to be, let me go back here and show the solving one more time. X is, I'm just going to subtract 1 from both sides. Log base 3 of 2 minus 1. So this is the point log base 3 of 2 minus 1. And the y value is 0. Don't know if you'll need it or not, but there it is for you. I think if you're going to be fortunate, these other examples I gave you don't have an x-intercept, so we don't have to worry about it again. All right, next, y is equal 3, 1/2 to the x plus 1 plus 4. In this particular case, notice that my b value here is less than 1. I don't have a negative in front of the x, so this is going to be a graph of decay. Okay. So instead of my graph looking like this, I'm going to have a graph that looks more like this. decay. All right. So now that I've got an idea of that, I also know that I'm not only going to have decay, but I'm going to have a horizontal asymptote at y equals 4. So here's my horizontal asymptote at y equals 4. Once again, if I look to see what gives me a 0 here, it's -1. So when I get ready to build my chart, I'll put a -1. 1 more than -1 is 0. 1 less than -1 is -2. I'm going to have my y-intercept because x is already equal to 0. That's kind of fun. And let's put these points in. When I put in a -1, I get 3 times 1/2 to the 0 plus 4. Okay, 1/2 to the 0 is 1. So I get 3 times 1 plus 4, which is equal to 7. Okay, so the first number I'm going to get is -2, 7. All right, then I'm going to put in, -2. I'm sorry, -1, 7. Holy cow. Let's go back, -1, 7. All right, let's try 0. When I put in 0, I get 3 times 1/2 to the 0 plus 1, which is 1/2 to the 1 plus 4. Well, 1/2 to the 1 is 1/2, so I'm going to get 3 times 1/2 plus 4, which is 3/2 plus 4, which is going to be 5.5. And so when I put in 0, I'm going to get 5.5 as an answer. Pretend I can actually get that at 0, 5.5. This was the point -1. That point's give me fits, isn't it? -1, 7. And let's try -2, see if it's even going to fit on my graph, because I know I'm going to be heading up in that direction. If I put in a -2, I get 3 times 1/2. -2 plus 1 is to the -1 plus 4. Don't forget I've got to do my exponent first. 1/2 to the -1 is the same thing as 1/2, which is 2. So I've got 3 times 2 plus 4. Doing my multiplication first is 6 plus 4, which is equal to 10. So I've got the point -2, 10 on my graph. Okay, I'm not going to have an x-intercept because I'm never going to get below 4. I'm going to join these 3 points together. Notice I've got exponential decay. So as pretend I actually went in that point there. As x approaches infinity, y approaches 4. As x approaches -infinity, y approaches -infinity. My domain, once again, is -infinity to infinity, as it is with any exponential graph. My range in this particular case goes from 4 to infinity. 4 is not included. All right, I think I have one more graph here for us. We'll try it, and then I'll send you on to try some on your own. Okay, as far as growth and decay, notice my b value here is less than 1, which is going to toggle me from growth to decay, but I also have a negative in front of the x, which is going to toggle me back, and I know this thing is exponential growth. Okay, so I know I've got exponential growth. However, this time I've got a negative here in front of the 3. What does that negative do in front of a graph? Well, if I've got a graph that's going with exponential growth and I put a negative in front, it flips it upside down. The shape of my graph this time is going to look something like this down here at the bottom. I know I'm going to have that shape because I have exponential decay, but I took that exponential decay and turned it upside down. All right, I don't have a k value here, and so I know that my horizontal asymptote is going to be at y equals 0. Now, what value for this exponent is going to give me a 0? 2 minus x equals 0 means that x is equal to 2. So I'm going to put 2 in the middle. I'm going to go 1 less than 2 and 1 more than 2 and see what values I get. Okay. Starting with 2. 2 minus 2 is 0. 1/3 to the 0 is 1. And so at 2, I'm going to get a value of -3. Let me try 1. If I put in a 1 here, 2 minus 1 is 1. 1/3 to the 1 power is 1/3. So I'm going to get -3 times 1/3, which is -1. And then finally, if I put in 3, I'll do this down a little lower because I'm going to have 3 times 1/3 to the 2 minus 3 is -1. I'm sorry, that's -3 times that, correct? Remember, it's very tempting to say this 3 times 1/3 is equal to 1. We do not do those two first. We have to do our exponents before we do our multiplication. Okay, so I've got 1/3 to the -1, which is 1 over 1/3, which is 3. So this is going to be equal to -3 times 3, which is equal to -9. So when I have 3, my y value is going to be -9. Let me put that in. I've got 3, -9. I've got 2, -3. And I've got 1, -1. 1, -1, 2, -3, 3, -9. And I guess in this particular case, I'm going to have to find my y-intercept. Where am I crossing the y-axis? So I'm actually going to have to put in a 0 also. Okay. Let me erase a little bit of this. So in this particular case, I've got -3 times 1/3 to the 2 power. Well, 1/3 squared, remember, don't do these first. Do your exponent first. I get -3. 1/3 squared is 1/9, right? -3 times 1/9 is -1/3. So I also have an intercept here at 0, -1/3. There's my y-intercept. I'm going to join these points together and say just a few things about these real quick. As x approaches infinity, f of x is going to approach -infinity. As x approaches -infinity, f of x is going to approach 0 from the negative side. My domain is going to be -infinity to infinity. My range in this particular case is going to go from, remember we start with the smallest value, which is -infinity, to 0. I hope this helps with your graphing of exponential functions. I will probably come up with a sheet to give you some more practice, and I'll see you during the next tutorial.